Hello, and welcome to Software Architecture Monday. My name is Mark Richards, and in this lesson, number 209, I'll talk about some of the common fallacies of software architecture. Now, a fallacy is something that we believe to be true, but is not true. And most of us are probably familiar with the 8 fallacies of distributed computing, but I'm going to show you 3 of the fallacies of software architecture. Now let's get going. Fallacy number 1 of software architecture is that software architects don't write source code. In other words, an architect's responsibility is to figure out and design and solve the problem through architecture. And it's up to developers to implement and write source code. This, everyone, is a fallacy. It is not true. In fact, developers, software architects, do in fact write source code. And as a matter of fact, most of the source code software architects write is production source code. But I want to talk about a trap that's easy to get into as a software architect when we do write production source code. And that is not to become the bottleneck on the team. Not to take the most complex area of the system, or maybe the underlying framework code of the system, but rather take some insignificant screen or maybe a less significant feature and work with the team implementing that particular feature. And the reason is because while a software architect does write source code, the problem is that software architect is doing a lot of other things as well. And when we as software architects get pulled away, the last thing we want to do is be in a critical path of that development team and the writing of the source code. Now, many times, I'm sure some of you even listening might say, Mark, in our company, software architects are not supposed to be writing production source code. Their role has changed. That may be true, but that doesn't mean that software architects cannot write source code. As a matter of fact, it's far from the truth. And let me show you some techniques. The first is writing proof of concept code. This is a way, as a software architect, of being able to verify a particular solution. Or if I have 2 solutions and I'm unsure which one to do, I may code both of those. By doing so, the implementation of that solution and that architecture starts to bring out some of the hidden trade-offs and implications associated with those 2 choices. So this is a really good win-win situation. A little tip, by the way, if you are writing proof of concept code for your company, my tip is this: unless you know for a fact that you're just going to delete it off of your hard drive that day, write the best possible production code you can. And there's 2 reasons for this. One, it gives you good practice in writing really good, effective source code. But also, chances are that proof of concept will act as a reference architecture and go into the Git repository. And do you want the worst code you slap together to be your representative code as a software architect? Chances not. But other ways is to look at the technical debt and maybe pay back some of that technical debt for the team. This is a way of being able to tackle that technical debt, pay that technical debt down, but also remain hands-on and help your team out at the same time. There's also other aspects of getting involved in production outages. Helping the team seek out a root cause of a particular outage keeps you involved in the source code. And finally, my favorite tip of writing source code is to write fitness functions, which are architectural tests, structural ones using things like ArcUnit, ArcUnit.net, NetArcTest, PyTestArc, and TSArc, or even custom fitness functions to measure some of the operational characteristics like elasticity, scalability, and responsiveness. All right, fallacy number 2 of software architecture There's always a perfect solution to a problem, and it's up to us as software architects to find that perfect solution. This, everyone, is a fallacy. There is no perfect solution to a problem. This is a fallacy. As a matter of fact, that fallacy is largely due to our first law of software architecture that we coined in our Fundamentals of Software Architecture book, and that is everything in software architecture is a trade-off. And it's up to us as architects to analyze those trade-offs. There will always be a trade-off to a problem, something that we sacrifice, maybe it's performance, for better security. And so here's my advice. First of all, don't strive for the perfect solution. Rather, strive for the least worst solution possible. This will help you as a software architect not to try to strive for perfection, but rather to analyze those trade-offs to find the most appropriate solution, the least worst one. All right, there's one more fallacy I want to talk about, and that's fallacy number 3 of software architecture. You see, as a software architect, you get to make all of the critical and important decisions for once. This, everyone, is actually, in reality, a fallacy. And let me explain and demonstrate why this is a fallacy. Let's say that you're a developer and you're writing some code, and suddenly you see that you have a high level of cyclomatic complexity. And this is going to largely result in unreliable and unmaintainable and untestable code. And so you choose as a software architect to leverage the strategy and also the template design patterns to solve this for the win. My question to you is this: who is going to challenge you on that decision you made as an architect? And the answer is no one. If you choose to split apart a class file or maybe combine methods, these are aspects, decisions, the naming of an attribute that developers make every day. And no one is sitting there challenging them. Let me show you another scenario. You're a software architect in charge of leading the CRM application, the Customer Relationship Management System for your company. And correspondingly, it has a very large customer or CRM database. Well, the problem is this: there's a lot of other systems in your division or department that need that customer data, and they all simply just access that. Well, as the architect, you realize you have 3 fairly serious problems. The first is security. All of a sudden, everybody has unfettered access to all the customer information. And maybe that's not appropriate, because there could be some aspects, some information, PCI or PII, that some systems and applications are accessing that shouldn't. The second challenge you're going to have is any change to the structure of that database, especially during a merger or an acquisition, or a major change of that CRM, is going to be near impossible, because it's going to impact every system that's accessing that database. Good luck trying to coordinate that. And third is we're not meeting our SLAs or our SLOs, our service level objectives, and because everybody is accessing the database with rogue queries and very long queries for reporting and analytics, that this is supposed to be our database, and our response times are horrible. So the solution the architect comes up with is to form what's called application silos. In other words, making an architectural decision, a critical an important decision for the CRM system to actually be effective. And that is this: only the owning application or system can access the database. In other words, everyone else has to ask me for the data. You can't access the database directly anymore. And this solves every one of the problems I talked about. I get better security, because now I am giving you the data. I, as a CRM, am choosing who gets what data. It also allows us easier structural changes to the database because I'm the only system that has to change. And third, we're now finally meeting our service level objectives in terms of responsiveness. Well, this is a great architecture decision, but wait. Everyone is upset about this. Can you imagine every one of these systems now has to change to decide on what kind of remote access protocol should I use to get to you? Should it be REST? Should it be messaging? I have a reporting system. How am I going to get the volume of data I need through a simple RESTful call? And here is the point of this fallacy number 3. Think about the developer making that decision. No one challenged them. As an architect, almost every decision you make will be challenged. It will be challenged by stakeholders who deem it too expensive or don't want to pay for it or think it's going to take too long. It will be challenged by other architects who have other ideas and notions about how it should work. It will be challenged by developers who think they have a better approach or that you don't understand the actual problem. So enjoy living life as a developer because you have a lot more freedom for your decisions than you do as an architect. So these are 3 of many fallacies of software architecture, which is why I named this particular lesson Part 1. So in upcoming lessons and future lessons, I'll add Part 2, Part 3, Part 4, however many parts I need to describe additional fallacies, things we deem to be true but are not, of software architecture. So thank you so much for listening. This has been Lesson 209, some of the fallacies of software architecture, Part 1. Stay tuned next month on the first Monday for the next lesson in Software Architecture Monday.